You reach over and turn off the lamp. The room goes dark. Immediately, your heart beats a little faster. Your eyes strain to see something, anything. You know your bedroom is safe. You checked under the bed. But your body doesn't care. It's already on high alert. You might even hold your breath for a moment. Why? The real answer is far stranger than you think. It stretches back hundreds of thousands of years, long before houses, before cities, before fire. It's a fear carved into your brain by evolution itself. And no amount of logic can make it go away. This isn't about being childish. It's about a survival system that saved your ancestors from being eaten. And it's still running inside you right now every time the lights go out. Imagine the African savanna at night, 200,000 years ago. Your ancestors huddled together, helpless in the dark. They had no night vision, no sharp claws, no thick hide. Their only weapon was a brain that could detect threats. But at night, that brain went blind. The darkness was a predator's playground. Saber-toothed cats, giant hyenas, leopards, all nocturnal hunters. They could see in the dark. Your ancestors couldn't. So what happened to the ones who didn't fear the dark? They didn't survive. They wandered too far, slept too soundly, and got picked off. The ones who felt a jolt of fear, an adrenaline spike, the moment the sun went down, they stayed close, stayed alert, and stayed alive. They passed that fear down to you. That fear became a hardwired alarm system. It's not a conscious thought. It's a reflex, buried deep in the oldest parts of your brain. The moment light levels drop, your brain's threat detection center, the amygdala, lights up. It doesn't wait for permission from your thinking brain. It sends a signal to your body. Prepare for danger. Your heart races, your breathing changes, your muscles tense. In the 1990s, psychologist Christian Grillon at Yale University discovered something unsettling. He called it the darkness-enhanced startle. He found that when people were in a completely dark room, even a mild, unexpected sound made them jump far more violently than in a lit room. Their startle reflex was amplified. And this happened even when they knew they were in a safe, locked lab. The dark itself was enough to prime the brain for threat. No logical reassurance could stop it. But why? Why would knowledge of safety fail to calm you down? Because the fear of darkness operates on two separate brain pathways. One is the low road, a fast unconscious circuit that goes straight from your senses to the amygdala. The other is the high road, a slower conscious route that goes through the cortex, where you can reason and recognize that you're not in danger. Neuroscientist Joseph Ledoux, a pioneer in fear research, mapped these pathways. The low road is faster. It can trigger a fear response before you even realize what you're seeing or not seeing. So when the lights go out, your amygdala gets a signal from your eyes. No visual data. To your ancient brain, no visual data means possible predator hiding. It doesn't wait for the cortex to say, it's just the closet door. It fires off the alarm immediately. By the time your logical brain catches up and says, relax, you're fine, your body is already flooded with stress hormones. You're in full alert mode. And you can't just turn it off. The fear gets even deeper when you consider another brain structure, the locus coeruleus. This tiny cluster of neurons in the brainstem is your brain's main source of norepinephrine, a chemical that heightens arousal and attention. In darkness, the locus coeruleus becomes more active, keeping you hypervigilant. It's as if your brain turns up the volume on every creak and whisper. Dr. Michael Davis at Emory University showed that the startle reflex is directly modulated by the amygdala and this norepinephrine system. Even rats, when placed in darkness, show a heightened startle response. In the dark, the system is already on a hair trigger. So when you hear a floorboard settle, your brain doesn't hear a house settling. It hears a footstep, and you're already halfway to a panic attack before you can remind yourself that houses settle. Now here's the twist. Even though you know there are no saber-toothed cats in your apartment, your brain doesn't have a delete key for ancient fears. Evolution doesn't work that way. It can't redesign you from scratch. It just layers new systems on top of old ones. Your cortex can learn that the dark is safe, but that learning is fragile. It's like a thin layer of paint over a rusty alarm. Under stress, fatigue, or even just the right horror movie, that paint cracks. Suddenly, your ancient brain takes over. You see a pile of clothes on a chair and your brain interprets it as a crouching figure. You're not hallucinating. You're experiencing the default setting of a brain built for survival in a dangerous world. This is why you can't sleep with your back to the door, why you pull your feet under the blanket, as if the thin fabric could stop a predator. Your brain is still running the same software it did on the savannah. But there's an even stranger twist. This fear might actually be useful, even today. In a landmark study, Dr. Andreas Kiel and his colleagues at the University of Florida found that when people see fearful images in the dark, their brains show enhanced visual processing. It's as if the brain tries to compensate for the lack of light by sharpening its internal threat detection. In complete darkness, your brain might even generate its own visual input. Ever seen shapes in the dark? That's your visual cortex filling in the blanks, trying to make sense of nothing. It's the same mechanism that causes you to see faces in clouds. But in the dark, it's biased toward threat. Because missing a predator is far more costly than a false alarm, so your brain overreacts. This leads to a modern paradox. You live in a world of electric lights, locked doors, and security systems. Yet, when you walk down a dark hallway, your heart pounds. You might even feel a presence behind you. That feeling is a ghost, not of the dead, but of your ancestors. Their survival is literally etched into your nervous system. You can't reason it away because it's not a thought. It's a feeling. It's a bodily state. Your brain and body are doing exactly what they were designed to do in low-light conditions. Prepare to fight or flee. Psychologist Peter Muris at Maastricht University found that fear of the dark is one of the most common and persistent childhood fears across cultures, appearing even in toddlers who have never been told scary stories. This suggests it is not simply learned, but deeply rooted in our biology. It's an inheritance. So, the next time you're lying in bed, staring at the dark ceiling, and you hear that little creak, remember, you're not broken. You're not weak. You're just carrying a 300,000-year-old safety system. And it's still working. It might be annoying, but it's the reason you're here. The real question isn't, why am I still afraid of the dark? The real question is, how did I ever convince myself I wasn't? You reach over and turn off the lamp, your heart races. And now you know why. It's not a flaw, it's a legacy.